So, hello everybody. So we are Anne Loth and Bruno Thomas. We are coming from the ICIJ. It's the International Consortium of Investigative Journalists. So it's the organization that released Panama Papers that we just saw before. So it's more about journalism than science. So thank you for admitting us. And so we are going to see how we could use an index machine like Elasticsearch or Solr to help journalists to find facts and stories among really big document corpuses or leaks. We call them leaks in journalism world. So we are going to see how we started from a legacy components and how we had some needs for the journalists and how we used that bricks to build another component or a project called DataShare, and we are going to see the challenges and how we tackle them. So first of all, just a little parenthesis. Legacy software is very often connoted negatively. It's seen like a drag that you're pulling and that is lowering the productivity of software development. Here is more at the first sense of the word, is something that is transferred to someone. So it's like an asset, and the asset has some drawbacks, and we are going to see how we use those assets and remove the drawbacks to address the new needs of the journalists. The second thing about legacy is it's capturing knowledge. So we used this component because there were knowledge about natural language processing and also what has been done before about the huge leaks like Panama Papers. And the other thing is that everyone is producing legacy at some point. So in fact, really fast after a few months of development, we are often finding that the code base that we built a few months before is already legacy. So the first brick was extract. It was a command line tool, and it was used on the Panama Papers, and it was 11 million documents, and it was 2.3 terabytes. It was used also on Swiss leaks and Luxembourg leaks, and it was about 10,000 lines of code. It was Java, and you can see the workflow here. So basically, it was scanning the file system. So we received some leaks on a USB key or a hard drive or whatever, and then it's scanning the file system and is putting all the paths in a queue and a shared queue. Then there are extractors that are based on Apache TK that are extracting the text and feeding a report map to be allowed to see afterward which file has not been extracted correctly. And then it's sending the text to a spewer that is outputting the text into several outputs like a REST service or file or stdout. We used with extract most of the time it was Solr. That was the index that was used at the time, and that was one of the problems that we were facing, and we will talk about this later. Then when all the files were indexed into Solr, Then there was another open source component that we used, was called Blacklight, and it's a Ruby on Rails software. And then this Blacklight is a kind of a framework that allow to build websites to browse some big corpuses of data, like and it's used, for example, by libraries or universities. And so we used it for the journalists to help them to use Solr, and without having to know actually the complexity of the indexer languages and inputs. Yeah, so it was basically quite simple. It's a front application and the backend in Ruby on Rails, and then the backend index. Then there was this. It was a repository. It was already called DataShare, but it was not in production. It was not the same that the knowledge center that was used by a lot of journalists. DataShare was a proof of concept and was doing quite the same at the beginning. It was parsing and extracting with TK also. The new thing was the 5, I don't know if you can read, but the 5 natural language processing pipelines that were used to extract named entities from the text and help journalism to have a grasp of the leaks quite fast. And that was indexing these name entities into the index. So the two new things here were the natural language processing, and it was using Elasticsearch index. And so we had quite overlapping between DataShare and Extract, and we wanted to do approximately the same as the knowledge center, but with improved user experience. And yeah, that's it. That was the 3 main bricks, and all the open source world that was bringing us some other tools, and we can now explain how we build DataShare with this.
So yes, so in a sum up, so that's the issues that we had to fix. So first, in Extract, the package was pretty big. The package in itself was pretty big, so we decided to split it into 2 parts. One was only the Java lib, so the jar that could be included that will be included in our new tool. And the other one part was the command line interface to use it through your terminal, but without any GUI. And we faced also a problem of scalability with the Solr index, because we had too many rows, too many documents in it. So we wanted to switch or to migrate from Solr to Elasticsearch to avoid this problem of scalability. Just as a reminder, yes, just like Bruno said, the Panama Papers was how many?
11.
So 11 millions of documents, and our last leak, I don't know if you heard about the Luanda leaks 2 weeks ago. About Angola, and it was more than 700 documents, so that's pretty... 700,000, sorry, forget a few zeros, documents. So yes, that's part of the problem. And about Blacklight, we had, so it's in Ruby on Rails. I have nothing about it, but it was pretty difficult to modify the interface, and I will come back on it later, but the web interface, the user experience is pretty important for us because journalists, but probably researchers, are not tech savvy at all, so everything should be well synced to make their life as easiest as possible and our life easy too. And another problem was maintainability, so about the bricks that we had, but also about the work that the journalists wanted to do, because they already have a tool that in production, so the one about blacklight, that was working. So we had to develop a new tool, but without any breaks. So they needed the same functionalities without any end of service, and with exactly the same documents. And so that was part of the issues that we had, and then the challenges. So as I said before about the huge amount of documents that usually get at the beginning of a leak, they get all those documents, and the first question is, okay, where should I begin? So the let's say new challenge of data share would be to give them some ideas to how could they start, and how it have a global overview about this leak really fast, and to answer some questions just like easy questions, just like how many documents, but also how big is the document, speaking about geographical location or people included in those documents. So just like a global overview. So what happened in these leaks? So that's challenging. That challenges that journalists encounter really often, but I'm pretty sure that researchers have quite the same too. So that's probably one of the reasons why we are here. And to answer all these challenging and faces all these issues, we developed DataShare. Here is the new schema of the tool. As you can see, part of the workflow is really the same than before, but we succeed in putting the experienced bricks that we had, just like extract in the new tool of DataShare. So there is extract here at the really beginning of the process, at the scanning and indexing part. And all the data extracted by extract, just like the well name, will be pushed into a Elasticsearch index. So that's a new one, and we needed to migrate the data from Solr to Elasticsearch, because it would have taken months to reindex all the leaks otherwise. And you can see here that we have the NLP. So at the really bottom, that's the NLP pipeline. So we just get the 5 NLP pipelines that we add and developed a common API to be able to interact with it, and so I don't know if I mentioned that before, probably not, but the NLP pipelines is just a way to collect named entities in the document that we extracted before. So yes, that's it. That's the new data share, and I think now it's time for a demo. Let's cross fingers. Yeah, it works. So here is our demo website about data share. Probably I should mention that it's an open source tool, so everything is on GitHub, and if you need to use it on your own corpus of documents, it doesn't have to be big, but if you just have document that you need to analyze, it's free for you. So here is an example on the Lux leaks, which is a leaks that we revealed a few years ago. So here is the list of the projects. So you may have numerous projects here, or several projects here separated. And if I click on LuxLeaks, I have first the number of documents in the leaks. So that's pretty important. And here is the list of documents. So that's the first step. And here on the left, you have the facets. So we built some facets on the Elasticsearch, and those facets are the response. So as a response about the global overview of the leak and of the document. So by example, here I can click on file types and I will see how many, so the different types of document that I have in my corpus and how many of documents of each type. So here in this corpus specifically, I do have only PDF. So yes, I have thousands of PDFs in that corpus. And I can do exactly the same for the languages. So I know in one click I can discover that I have some documents in English, French, German, and Italian. So it gives a first overview of the languages of the documents in that corpus. And about the NLP pipelines, here are the results. So so all the named entities extracted, that are from. Oh, thank you. That's about people, localization, and organizations. So here, if I click, I can see that in my, so first in my more than 1,000 document, I will have 47,000 different people mentioned in it, and one of the main mentioned is Cole, Mr. Cole, which, as you all know, is the main shareholder and stakeholder of the LuxLeaks, but we didn't knew it before data share and before reading the documents. So that's a good add for the corpus. And I can do exactly the same with the locations. And here I will see Luxembourg, US, UK, which are the main countries mentioned in that corpus. So that's data share, and that's the way we developed it. So that was the past and the present of data share. And about the future, we have lots of. We would like to develop lots of things, just like adding comments on documents, because I also have access to documents. So we would like journalists to be able to put comments directly on documents. And creating some dashboard on each project to have a really quick overview of I don't know how many documents on which type, and about the creation date, just like a simple histogram on the creation date. And we would like to redevelop the installers, because now it's based on Docker, and we have some doubt about it, because we have lots of difficulties with Docker. And the point is that journalists, I said it before, but that's really important for us, that journalists are really not tech savvy at all. So one of the most important point is to have a well-developed, well-stocked interface and easy to manipulate and easy to navigate and dig into the corpus, and easy to install on machines and on computers for everybody. And we do have yes, and we wanted to develop a plugin architecture to let developers to be able to develop their own plugins. So that's it, and I hope you will find a usage for that tool too, and feel free to open issues.
Thank you.
Should I take all the micro? Yeah.
Has it been used on the purpose of documents released to journalists by Edward Snowden?
N-
It's a huge corpus
Which one? The Edward Snowden corpus?
of documents released by Edward Snowden.
No, because we hadn't. I don't know. I don't think so. Oh, sorry. Yes. So if this tool has been used on the document released by Edward Snowden, so I don't think so, because first the tool is quite new. We released the beta version 1 year ago, and I don't know if those documents are public or not. So maybe that's the reason.
Yes, but they are in the hands of journalists, so your colleagues, you can use
Not as far as we know now. They are not using it.
They should. Yes.
You know Marcus Mandolka? You work with him? Open semantic search?
We heard about it.
Yeah.
We've heard about it, sure, because it does quite the same than us, I think, but not as good as us.
So you have compared already with
Sure, sure. There are lots of tools so it's not a new need because it has been the same need for years and years. So open semantic search is doing more or less the same, and there is the one from OCCRP,
OCCRP.
Aleph. Aleph is another tool that do more or less the same, but I think that our is prettiest.
one more question, if I may. How to detect languages? With what?
How do you detect language?
Oh.
The question was the language, the programming language used.
No. The language of the document. Is it in Spanish? Is it in German? Is it how we actually process it? Because it's very important if you natural language processing need to know before what kind of language it is.
Yeah.
Push Russian to the English one, you get very weird results.
So the question was how many languages are supported by the NLP pipelines?
How do you figure out which one it is?
Oh,
When you take the document in?
yeah, it's a question of the chicken and the egg, because yeah, when we are detecting the language with a small framework that is called a language detector, and the problem is that when we are doing OCR, then we have to provide a language and we have to make run OCR to know what language is the text. So for the moment, the OCR we are using Tesseract, and it's supporting I don't know, I think it's 30 or more languages. But so we are extracting text from a lot of languages, but the extraction of name entities are run on only 5 languages, or 6 now. I think there is the Chinese, and yeah, English, German, Spanish, and I think, and French.
A follow-up. Then the question could be also like, do you have features to let journalists actually declare that they are suspect that the name entity recognition algorithm failed, or the OCR?
So no, not. The question was, is there some feature to let journalists know that the extraction of name entity failed? And no, it's a feature that we are going to develop. Is how we are conciliating all the named entities. For example, knowing also that Donald Trump is the same as D. Trump, and it's like OpenRefine could help us, for example.
Another question?
Yeah.
Curious, what kind of hardware do you actually need to like run through this whole process? Like a desktop computer or how much?
So we are using what we are trying to do is what I call total scalability. Is we have built because we have partners that are in countries where there are not a lot of resources, like Africa, for example, and so we made a version with embedded Elasticsearch that could run on a Raspberry Pi. But at the same time, we want it to be able, and we are running the extraction of bit leaks like Panama Papers on cloud computing on 30, or I think the most, 30 nodes at the same time.
Can I use the shell to extract the network of citations of named entities from the corpus?
Sorry, I did it.
Once I've imported the whole corpus, like here in your example, can I extract a network co-occurrences of named entities from the documents?
No.
No.
Question.
So one of the sorry, yes. So the question was from a document, can I extract the how do you say that, corpus of co-occurrence of, sorry,
Co-citations network.
co-citations, no, network of named entities in document. So the simplest answer is no, and the longer answer is we plan first to be able to export named entities as CSV. So that would be the first step, and after that you will do your own tricks.
Thank you.